Okay, video problem 18, orbital diagrams and electron configuration. Here we actually get into orbital notation. And so what I'll do first is I'll write the electron configuration, and then I'll show you the orbital notation of that electron configuration. So give the orbital notation of the following elements. So like I said, first I'm going to do the electron configuration. So hydrogen is 1s1. Now the orbital notation looks like this. So we have the s, and there's only one s orbital, so we only draw the one, and then we only have one electron, and we draw that as an arrow pointing up. So that's the orbital notation of hydrogen. Now carbon is a little bit different. Carbon is going to be 1s2, so that's full, 2s2, that's full, and then it's 2p2. So let's take a look at the orbital notation of that. We've got, again, here's the 1s, there's only the one orbital. So there's only one s orbital, so that's full. Can't put any more electrons in that. One pointing up, one pointing down. They have opposite spins. And then we move on to 2s. So there's the 2s. There are two electrons there, so one pointing up, one pointing down. And then we move to the 2p. So there are 1, 2, 3 p orbitals. There's px, py, and pz. So that's why there's three of them. So we call that 2p. Now the first electron goes there. The second electron goes in the orbital next to it, because each orbital of the same energy gets one electron before anybody gets a second electron. So let me show you what that looks like with oxygen here. So oxygen is going to be 1s2, 2s2, 2p4. So here's the 1s, here's the 2s, and then again we have 3 p orbitals. So we put one there, one there, one there. Everybody gets one, and then we have to go back and give a second to that one. And now we can really see that with iron. It's a D block. So what is it? It is, yeah. So it's 1s2, 2s2, 2p6, 3s2, 3p6. That's through the third period. Then fourth is 4s2, 3d, 1, 2, 3, 4, 5, 6. So it ends with 4s2, 3d6. Okay, so again, the s only has the one orbital, 2 electrons. That's full. So we go to the next highest energy level. That's full. So then we go to the p's. 1, 2, 3, 4, 5, 6. So that one's full. Then we go to 3s. Yeah, boy, this is a big one, huh? Then we go to 3s. 1, 2, then the p's. 1, 2, 3. Go back and give everybody a second one if we can. So that's 3p6, that's full. Then we go to 4s. Then we go to 3d. 1, 2, 3, 4, 5. There are 5 d orbitals. dxy, dyz, dxz, dx squared minus y squared, and dz squared. So these are all the 3d. So everybody gets one. 1, 2, 3, 4, 5, and that's because of Hund's rule. And then here's the sixth one. So there's orbital notation.